Let's see, what do we got? Perfect problem 2 for Math 65. Question 1. Hopefully there's just one question. Yeah. So the only question, I don't know why it's numbered 1, is to solve this system of linear equations, which is a little tricky because there's 3 of them. Maybe I'll call them A, B, and C for future reference. And 3 variables. So what you want to do is take 2 of these 3 and eliminate one of the variables. And take 2 different ones of these 3 and eliminate one of the variables. And then what you'll be left with is 2 equations with 2 variables, which is something we know how to solve. So what I'm going to do is use A and B over here and get rid of the z's. That kind of lines up naturally, right? Positive z, negative z. So I got 2x plus 2y plus z is equal to 2. And x plus 3y minus z is equal to 0. And if I add those together, I get 3x plus 5y plus 0 is equal to 2, which is good. This gives me an equation. Maybe I call it, well, I'll just leave it at that. Now I want to pick 2 more of these equations and eliminate z from them. So I think the easiest will be to choose B and C. And the reason I choose B and C is because I could just double B, and then when I add them up, I'll get rid of the z's. So if I do 2 times B, maybe I even write this, 2 times B gives me 2x plus 6y minus 2z equals 0. And C gives me, sure, I can label all of these. A goes right there, B goes right here. C gives me 3x minus 3y plus 2z equals negative 2. So if we add these equations together, we get 5x. And what's that, plus 3y? Nothing equals negative 2. So we got these 2 equations up here. They kind of look similar. Maybe I'll change my color. Let's see, so it's not easy to see anything that will cancel out immediately. Let's see, I guess we could multiply this guy by 5. So let's see, this, how do I write this? Maybe times 5 gives me, doesn't give me 6, gives me 15x plus 25y is equal to 10. And then this guy right here, if I multiply this guy by negative 3, I'll get negative 15x minus 9y is equal to positive 6. Negative 2 times negative 3. So maybe times negative 3. Gets me to here. And by choosing 5 and negative 3, what I've done is I've gotten rid of the x's. 25y minus 9y is 16y. 10 and 6 is 16. So y is equal to 1. Maybe we change color again. All right, let's see. We know y equals 1, so we could plug that into one of these equations, maybe the top one, since the numbers are all positive. Let's see, 15x plus 25y is equal to 10, but y is equal to 1, so 15x plus 25 is equal to 10. Subtract 25 from both sides, and you get 15x is negative 15. That's negative 20, subtracting 25 from both of these numbers. And divide by 15, you get x is negative 1. And now finally, we got x equals negative 1, y equals positive 1. So we can plug those both in to, well, we can plug it in wherever we want. Let's see, where would be the easiest way to solve for z? Maybe this top guy here, because this top guy has z all by itself. So, geez, running out of colors. That top equation says 2x plus 2y plus z is equal to 2, but x is negative 1, so 2 times negative 1 plus 2 times y, but y is 1, plus z equals 2. So negative 2 plus z equals 2. 0 plus z equals 2. Z equals 2. So we get for our solution, x is negative 1, y is positive 1, z is positive 2. And that there is the end of this perfect problem.